Welcome everyone. In this video I'm going to show you how to connect this dust sensor and this gas sensor to an Arduino Nano. Here I just want to show you that it is connected together on a breadboard, and I will show you some drawing where I try to clean up this mess and show all the connections in a better way. But I just quickly show you what is what. So this dust sensor is basically infrared LED light and also an infrared receiver, let's call it like that. So you generate a pulse here in the Arduino, and that will light up the dust trapped in the air inside this chamber, and the light reflected from that dust is captured by the infrared receiver, and that will show up as a voltage on the output of this, because there is a small amplifier in this which will generate a small peak or a small voltage on the output, and you capture it with one of the analog digital converter pins of the Arduino, and basically that's all. And this gas sensor can capture the different volatile gases, but we will use it only for the CO2 detection. We will be able to capture it in ppm amounts, a few hundreds to a few thousands of ppms, and we can also check the temperature. So there will be three things measured by this device at this moment, and I will demonstrate those three things: the amount of dust, the amount of CO2 or other gases, and the temperature. So all the data from these two devices are connected by the Arduino Nano, and it is forwarded towards the computer. And I will show you how the raw data looks like, and also I will show you how the processed data looks like on a more fancy chart or a more fancy software, which is written for this purpose, to visualize and log the air quality data. So let's jump to the drawing and the code now, and let's discuss everything there. So let's talk about the circuit and the connections first. So you can see the Arduino, the CCS811, and then the dust sensor. Let's start from the CCS811 gas sensor. So as you can see, there are only 5 connections. So we connect the VCC to the 3.3 volts. It's very important that it is not the 5 volt connection, but it's the 3.3 connection. And then the ground goes to the ground of the Arduino. And then we have the SCL, which is the clock pin, and that goes to the A5. And then we have the SDA, which is the data pin, and that goes to the A4, as it can be seen here. And then we have this WAK, WAK, that goes to the ground again. I just did not want to mess up my already messy drawing, so this is also connected to the ground. So this is very clear, and here we have the chip. So for example, you can test it by blowing on it. So you will introduce carbon dioxide to the sensor, and also because of the temperature of your breath, the temperature will also change, and not only the output data regarding the gas amount. So we are done with this sensor. You can see that the connection is quite easy. And then we have our dust sensor here. So first of all, let's just concentrate on this part here. So this is what this gas sensor on the inside. So it is basically 2 parts. We have an infrared LED light, which is a light source, and then we have a diode, which is basically capturing the reflected light from the dust particles. So what happens inside the box is that you can drive this dust sensor by creating light pulses, as it is shown here. So you create light pulses at every 10 milliseconds with the width, so this pulse width of 0.32 milliseconds. And what is happening within these kind of pulses can be seen here. So the LED is switched off. So we switch on the LED. Here you can see the rising edge. So the LED is switched on, this guy here. And we keep it on for 0.32 milliseconds or 320 microseconds. And you can see that the output pulse is starting to rise, and then it saturates after 0.28 milliseconds. So when we switch on the LED, you will see it in the code. We wait for 0.28 milliseconds, and then we do a reading here. So we basically read out the pin number 5 with our Arduino. And then after 0.32 milliseconds, we turn off the LED. And then we wait again for this amount minus the pulse width. And we do another measurement. But what is important is that you can see we switch on the LED, we wait this amount of time. So this is 280 microseconds. And you can delay microseconds with Arduino. We wait, and then we read it with the AD converter of the Arduino, and we switch off the LED, and that's all. So it's very simple. And how we convert the data is basically based on this chart here. So the dust density defined in milligrams per cubic meters is proportional, it's linearly proportional until this amount to the output voltage. So you can basically pick a few points here and then read the voltage, which is corresponding to the dust density, and then you make a linear fitting. So you will get a function, a linear function. And then at the end, you will only have to plug in the output voltage here. And you get this and this guy from the fitting. And the Y will be the dust density at the end. But this is implemented in the code, so you just have to check the code, and that's all. So coming back to the circuit, I numbered the pins here on the connection and also here according to this kind of layout. So you can see 1, 2, 3, and here you can see also what is what. So the V LED is the voltage for the LED, so basically the plus side, and then there is a ground connection, and then the LED connection. So this is where we like switch on the LED, and then we have a ground again for the circuit itself, and the V0, which is the black wire, is the output. So maybe this is not V0 but V and capital O. Yeah, and this is the output voltage. So this is what we will measure with the circuit with the Arduino. And then the VCC is the power supply of this amplifier circuit. So what you can see here, you can probably understand it, but let me explain. So the pin number 1 is connected to a capacitor. This capacitor is usually provided with this kind of circuit if you buy it. So, 220 microfarad and 16 volt electrolytic capacitor. So you see that the positive side of this is connected, this capacitor is connected to the pin number 1 here, and the negative side goes to the pin number 2 and also goes to the ground, which is also connected to the pin number 4. So the ground is connected to 4, 2, and the negative side of the capacitor. And then, so we know where 1 goes, we know where 2 goes, and we have the number 3, which is here, is the LED. So you can see that that goes to the D2. So in the code, the D2 will turn on the LED. So basically generate this pulse here. So we are just connecting this wire to the output of the LED. So this is done. And then the 4, we discussed that. That also goes to the ground as it is defined or shown here. So S, G, and D. So this is connected to the ground, as you can see. And then we have the pin number 5. So if we go to the 5, this is the V, capital O, so the voltage output. So you can see that we go down along this green line here, and then we are connecting it to the A6. I just picked this leg, it doesn't matter, you can connect it whatever pin which is allowing analog digital conversion. But this goes to the A6. And then the pin number 6, which is the VCC. So firstly, that goes to the plus 5 volt. That is quite clear, but let me just clarify it. So this is plus 5 volt. But also the pin number 6 is connected to a 1 kilo ohm resistor. And that is going back to pin number 1. So the pin number 1 is connected to the pin number 6 via a R equals 1 kilo ohm resistor. So you can see, so here there is a junction, and then this junction connects the positive side of this capacitor, one side of the resistor, and goes to the pin number 1. So this is also clear. So I hope that this kind of drawing is enough to understand how to connect, and I hope that my explanation of how this circuit works was enough. So now let's jump to the source code of this circuit, and let's see how this works. So here is the code. So for the gas sensor, we have this pre-made library, so we don't have to do anything else than just connecting or including this library. And then we create this CCS. We create a variable to store the CO2 amount and the temperature. These are both related to this sensor circuit. And then we have the dust sensor. So we will measure the output voltage by using the A6, as I showed you on the drawing. And then we will turn the infrared LED on and off using the D2 connection. And we just define a few variables here. Actually, now I will just use this because I'm using my own software. So I will do the calculations on the computer and not on the dust sensor or on the Arduino. But if you need that, then you can use some other variables here. And then we will use a string where we store the output data, so basically the data which is sent to the Arduino. So in the setup, we start the serial connection and just print out some random data. So here I put a star because I want my software to neglect those kind of messages or data which is starting with star. That's all. So here, if we could not start this CCS, then we just print an error message and stick to this loop basically. So we stop here, and that's all. And then we can jump to here. So we calculate the temperature by using this feature from the library. So this calculate temperature, and for that we can set up a temperature offset. So first we need to measure the temperature, and using that we just create this offset, and we also define our dust LED pin, which is the D2, as an output, so we can control it. And here this is the main loop. There are basically 3 functions, and the name of the function is quite self-explaining. But what is happening here is that we check if there is something on the serial, which is hopefully just a single character, then we read that character and put it in this variable, this comment character, and we set up a switch case statement, which is not really necessary, but if you want to add some more control features, you can just copy and paste this and replace this character to your own things, and you can do other stuff. So basically it checks the character that we have just read from the serial, and then if it is a capital S, which is standing for start, then we step in this loop, and while this serial read is not a capital N, which is for me no, so we don't measure anymore, we just loop through these kind of functions all the time. But as soon as we send an N character to the terminal, then this will stop and wait for a command again. So that is happening here, and we just run one function, wait half a second, run the other, wait, and so on and so on. So the measured dust is very easy. So if you remember the circuit, if you remember the circuit and how it works, then you can see that we have to turn on the LED, and then we wait 280 microseconds. So then the output voltage will reach the peak and it will saturate. And at that time, after waiting 280 microseconds, we fill in this variable with the digital data, so basically the voltage represented in bits from the A6 pin. And then we turn off the LED. So this is what this measuring part consists of. And then we measure the gas and the temperature. So if we can reach the device and we are not reading, so the device is available for the conversion and stuff. So we fill in or fill up this variable with this getECO2 function from the gas sensor. And then we also just read the temperature, and then we also calculate it. So this is how the offset and all the stuff is taken care of. So we just basically fill in the CO2 amount and the temperature variables, or the values of them. And then if there is something wrong and we cannot reach the sensor, then we print an error message and just wait here. And then print formatted data. This is also very simple. So we just make a long string here. So we convert the temperature to a string and then make a tab, and then the output bits are also converted to a string, and then there is a tab, and then the CO2 amount is again converted to a tab, to a string, and then there is nothing else. And then we just print it out as a line. So this whole thing, it looks like something like this, but there is only a tab between them, and there is a line break basically. So that comes from this print ln, and that's all. So I can show you how the raw data looks like, and after that I can show you my software, and that looks a bit more fancier, and we can check with that as well. So first let's just take a look at the terminal. So we have connected everything, and now you can see that we already have our message here, and that is the same message that we defined in the setup part of this software or code. And now everything is just waiting for a character S, capital S, and then we will start receiving data on this terminal. So let's just send this character and let's see what happens. So now you can see that we are receiving the temperature data, and then we have the dust, the amount of dust, but this is raw data. And then here in ppm we receive the CO2 amount, so you can see it. So this is the temperature, and then this is the bit, the output bit from the dust sensor, and then this is the CO2 amount. So now what it would be a nice demonstration, I will blow on the sensor and you will see some change. So now I try that. Now you could see that there is a small change here. But as I talk and I lean towards the sensor a little bit, then we can also see some changes. But you can see that the baseline is somewhere around 400, and actually that's the minimum that this device can read. And also if I just moved around the air, the CO2 amount can also change, and also the dust. But I will do some better demonstration, but for that I take my own software and I will use that because it's more spectacular. So now let's stop the measurement. So I send an N message, and then there is no more data. So this is all. So now I will jump to my own software and let's see how that works. So this is the software that I made. So here there is a small part which is basically the same terminal that we saw previously. So if I enable, then in this part the input data will turn up, and then here I can send messages and I can connect to the selected COM port and so on and so on. And here I can enable the channels. I will enable everything because I just want to demonstrate everything. And here there is just some fancy feature, so we can save the output data into a file. We can pick what kind of delimiter we used in the Arduino code. So if we have something else, then tab, we can choose that. The time window is basically the time after which the chart is getting shifted out towards the left. So now it's 600 seconds or 10 minutes. So after 10 minutes, when a new data comes in from the right side, basically, then the very first data from the left side is getting shifted out. And then the measurement time, you can just define that you want to measure for 75 minutes. It's just turns it off. So after 75 minutes, you can turn off the measurement automatically. But now just let's see what happens if I press start. So we can see the data now. So the dots are the measured data at the certain moment, and it comes like every 1 second, as you can see. I set up the delays like that in the Arduino code. And then the lines are the average data of the day of the measurement, basically, and you can see that how it goes. So now what is a good demonstration, and I did not show you previously, I will light up a match and play around, because that will drive the dust sensor crazy. So I have a match here, and I just light it up and see what happens. So you can see that there was a huge jump in the CO2. I just moved close with the burning match, and then the dust is not really changing, that's the black. But now I stop the match, and then I move the match below the dust sensor. So now it is changing, so you can see that the dust changed here. It's not too visible, unfortunately, because the scale is different, and I had to use a secondary y-axis, and I put two data on the same y-axis, but you can see that the dust density went up after I lit the match. So you could see this. And also if I put my finger on the temperature and the gas sensor, then it is moving up a little bit, as well as the CO2 amount, and then it should go down nicely, and it goes down nicely. Or if I blow on it, you can see that I changed it a little bit. So the green dots are jumping up and down a lot. And here you can see the actual data. So the temperature now, it's like 25 degrees, and this is the dust density in micrograms per cubic meters. And then CO2 in ppm, and these are the average. And I would rather trust the average data, because that's much better, because there's a little bit of a fluctuation in the beginning. But you can see that it works, it is stable, and everything is nice. So basically this is all. So I showed you how to connect these two devices to the Arduino, and I showed you how the source code works, and I showed you this additional software that I made, which can be used to visualize and also log the data in a file. So now I just stop this measurement, and I just show you that this is the txt file, and we have all the data saved in the txt file. So everything is nice. But what's more important is that we can nicely visualize everything. So I hope that this tutorial was useful for you and you learned something. And I hope that you will enjoy this device if you build it. And don't forget to subscribe to the channel so you can get some new projects that I'm working on, and you can get some updates about them. So see you in the next video.